Good afternoon, and welcome to the Illinois Sustainable Ag Partnerships 2022 Risk Management Webinar Series. I'm Megan Baskerville with the Nature Conservancy and Chair of the ISAP Steering Committee. We're glad you're with us today to help us bust some conservation myths over the next 3 weeks. First up, we have a great lineup of speakers today: Dr. Jerry Hatfield, Kirk Kimble, and Frank Rademacher, highlighting the on-farm benefits of using cover crops. A little bit about the partnership. Since 2017, ISAP has been working to create a network that supports a systems approach to improve soil health and reduce nutrient loss. The 15 member organizations work collaboratively throughout the year to provide consistent technical assistance to Illinois farmers and advisors on soil health and conservation drainage practices. More of our resources can be found at ilsustainableag.org. But for now, I welcome ISAP's coordinator, Jean Brokish, to guide us through the rest of this afternoon's event. Jean?
Thanks, Megan. You can hear me okay?
Yep, I'm good.
Okay, great, thank you. So yeah, just a few quick housekeeping tips before we begin. Welcome everybody, of course, and this is GoToWebinar platform, so the audience is automatically muted. You don't have to worry about muting yourself. You should locate or see a small dashboard similar to what is shown on the slide here, and if you don't see it, you might just look for an orange arrow somewhere near your video monitor, and you can expand that. And within that, there's two areas that you can use. One is the question and answer button there. If you expand that arrow, it will allow you to submit some questions for our panelists. You're welcome to submit a question at any time, and feel free to tag your question for a specific presenter if it's appropriate. And then the chat, you can chat panelists and staff, which are like myself and Megan, but just reserve those for any technical issues. We're really hoping that you all can use that question function for your questions when we get to the panel discussion. We'll tackle as many as we can there. I guess the last thing to kind of know is this session has been approved for continuing education units for CCAs, and we'll have that QR code at the end. So as we do that wrap up, if you do have the CCA app, you can pull that out and be ready to go to scan that QR code for, we have, I think, a half an hour of nutrient management and a full hour of soil and water management here today. So with that, I'll just kick us off here with the introduction. Megan mentioned we have a great lineup of presenters, and we'll hear first from Dr. Jerry Hatfield. Jerry Hatfield is a retired director of the USDA ARS National Laboratory for Agriculture and the Environment in Ames, Iowa. Jerry's research really explored the interactions among the components of the soil, plant, atmosphere continuum, and how they interacted with air, water, and soil quality, and how all of that came together under different farming systems and the responses to water and nitrogen interactions across different soil types. So very much like what we're talking about today, and looking forward to Jerry providing a good foundation for us. One thing to know, Dr. Hatfield is an accomplished author. He is the editor of Agroecosystems, Geosciences, and Environment and Technology. He's the editor of a journal called Agroecosystems, Geosciences, and Environment, and he's the technical editor for Agriculture and Environmental Letters, and has earned numerous awards, including being inducted into the ARS Hall of Fame, recipient of the Hugh Hammond Bennett Award, and is a fellow for the American Society of Agronomy, Crop Science Society of America, and Soil Science Society of America. There are a lot of multi-syllable words in there, Jerry. Thank you for joining us today and laying a foundation for us, and I will just turn it over to you. We can go to your next slide.
Oh, there we go. Everybody
Perfect.
hear me now?
You sound great. Yep, you sound great.
Thanks, Jean. Thanks, Megan. I mean, it's a pleasure to
be with you today to talk about the benefits of biologically active soils. And you really begin to think about these dynamics and everything, and that is that we are now beginning to understand the role that biology plays in our soils. And I just let this kind of code it as letting soils express their full potential. I mean, let's come back and begin to look at this. I'm going to kind of weave this through this story this afternoon so you can begin to understand some of the dynamics that are going on, some of the opportunities we have with management, and how we can use this to our advantage. Next one, Megan. If we think about the functions of soil, and if you look at the diagram from the FAO, the Food and Ag Organization of the UN, I mean, they list a lot of different soil functions, but if we boil those down just to what agriculture needs in terms of functionality, is that we need to be supporting our plants. We want the plants to stand up. Soils are a water reservoir. They're a nutrient reservoir. Right now, there's a lot of attention paid to what soils have for carbon cycling. We also use them for a lot of decomposition of pesticides, antibiotics, and things like this because of the microbial activity within that. So those are the functions of soils that we need to be paying attention to because they're critical for agriculture, not only now, but as we go forward. And let's go to the next one. And if we think about all of this and just come back and see what have we done over time in this, and I use the Morrill plots and that are in Illinois and the Sanborn plots that are in Michigan. These were sites that were established back in the before the 19th or the 1900s. And you look at this and the top line on there in the corn, oats, hay rotation, you know, which we would assume to be fairly good, has still lost about 35% of its original soil organic carbon. But if you are on a continuous corn system, you know, through the 1990s, it lost about 60% of the original carbon. That's not, in Morrill plots are not quite as bad as the Sanborn plots, in which the continuous corn has lost almost 70%, and it lost it during the first 30 years of cultivation and all that. So we have an impact of what we've done in terms of agriculture. Go to the next one. If we think about this, we've changed our soils and we've reduced our ability to support ecosystem services. We've removed organic matter through tillage. We know that as we till these soils, we see a burst of CO2 going back out. We can see organic matter begin to decline. We see that as a result of crusting on that surface. The aggregates are no longer as stable. We've also instituted a set of cropping practices that really limit the return of carbon back into the soil. You know, we think about this is that you know, we're growing a lot of crops, but one of the things we saw in a long-term analysis from some data in Ames that we had over 16 years of measurements, both in soils as well as CO2 exchange, is that we were losing 1,000 pounds of carbon per acre per year out of these soils, and that was under a system, a conventional tillage and a corn soybean rotation. So all of that means that as we've lost organic matter, we limit that carbon coming back. We are seeing increased erosion rates. We're seeing increased soil degradation. If you look across the central part of Iowa here in that prairie pothole region, you'll find that those knobs that we have typically with Clarion Canisteo soils, if you look at pictures from the early 1970s until now, that those knobs are 3 times bigger today because they've lost organic matter out of them, and those are our low yielding parts of the field. So what that all means is that we've reduced the functionality of the soils. They're no longer able to hold that reservoir water. They are limited in terms of nutrient cycling. And we've made our soils really dependent and our cropping systems dependent on external inputs. And so all of this is really about how do we begin to restore that in terms of looking at increasing functionality of that soil. Let's go to the next one, Megan. If we think about this, we'll look at the diagram on the right side as well. First, is that if we want to improve our soils, the first thing we have to have is biological activity. Is that we do not restore our soils to where they're at. And we have a lot of attention paid to regenerative agriculture. We have a lot of attention paid to soil health practices today. But in reality, all of those revolve around being able to restore biological activity. And there are two different dynamics of this. These invisible and dynamic processes. You know, we don't see organic matter turnover. We don't see a nutrient cycling going on in there. We see those in diagrams. But what we do see is improved soil structure. We see improved water availability within that. So those are the visible outcomes. And so I think about this as a ladder in which the first rung on that ladder that we step up is how do we get biological activity? How do we get that microbial activity back? And so we think about these indicators of soil health. A lot of attention being paid to CO2 coming out of that, which is basically a reflection of how much microbial activity there is. Obviously, there's a lot of attention being paid now to soil organic matter changes, looking at the carbon markets and carbon cycling. But we also see it in terms of nutrient availability. We see it in terms of aggregate stability as we begin to look at all these different practices going on. So you can begin to think about how all these pieces come together. And so let's go to the next one. And you think about this, there's a paper that Wishmeyer and colleagues put together that basically said, what are the things that cause soil organic carbon to change within our soils? And the number one that extended across time and space, when they looked at a large number of research articles across the world, is that they needed to have microorganisms and fauna. The thing that really caused soils to change was the ability to support a microorganism and fauna structure. The next one was texture and clay, because that's where a lot of our nutrient cycling is coming from. And then it ended up in land use and management. That really is about how do we put our crops in different rotations and how we were tilling those soils. Then you ended up with vegetation, climate, topography, parent material, and finally, soil physics and chemistry was the bottom piece of this. And so you look at that exchange between the soil physical, chemical, and biological processes going on in soil, is that biology is the real driver of what causes soil to change. And so it's a matter of how do we maintain our biological systems in all of this. Megan, let's go to the next one. If you think about this, I'm going to spend the rest of the time talking about cover crops and how it all changes, but I want to do it in two different time scales. First one is what happens in the short term, and then what happens in the long term. We can think about the short term in terms of what do we do relative to water, what do we do in terms of temperature responses. Both of those are obviously important for biological activity because biology wants four things. It wants food, water, air, and shelter. And same things that you and I want as basic needs for life. We want to have a drink, we want to have air to breathe, we want to be kept comfortable in terms of temperature, and we want to be left undisturbed. And that's really what that shelter piece is in all of this. And so we'll talk about what happens in the short term. In the long term, we can talk about what's going on in terms of soil organic carbon. We can talk about aggregates. We can talk about nutrient cycling, all the things that we begin to see in the longer term aspects of this. So let's go to the next one. And if we think about the short term impacts of cover crops, I'm talking about within the first season of putting a cover crop out there. This is not a second or third, this is the first season. I'll just use this example on there, is that continual cover provides three advantages for soil water. I'm a big advocate that we need to be thinking about how do we manage our water in terms of this overall process. So we see three things that are going on. The cover crop protects against raindrop energy. So any aggregates right at the surface, that energy is absorbed by the cover crop. Water then slowly moves down through that cover crop material, gets into the soil. It's not, that energy is dissipated, and so the water just soaks in very nicely. The second piece of this is we reduce soil water evaporation. So that, and what we see is that adding that residue layer on the surface reduces evaporation by as much as 80%. And so we're putting that water back into the plant, not necessarily into the atmosphere. And the other piece of this, which we discovered, is that when we start adding this cover crop and the residue that's left on the surface, is those plant roots are very near the surface. So they can take advantage of small rainfall events. So instead, in the half-inch rainfall event that we have, is that it penetrates in that upper 2 or 3 inches of that soil surface, and we see plant roots that are right there. That's in an area of very high microbial activity, a lot of nutrient cycling going on. So these are 3 things that we begin to see when we change in the first season. So putting that cover out there does all these things automatically. Let's go to the next one. The other piece of that, I'll just show you one example. This is a slide I got from a group I work with in Kansas. I happened to have a 2-inch rain in 1 hour, and one of the guys went out into the fields near his farm, collected runoff off of a cover crop field and a no-till field and a tilled field. And you can see how much sediment was in that field and all of this. And the cover crop, you know, you aren't seeing any sediment in there. A little bit, obviously, we changed color. Even the no-till field, there was some movement of soil out there. And a tilled field, you can see just how muddy that whole thing is. So you can see that we do change the water balance. We change the dynamics. How do we handle that? Infiltration rates, often when we have cover crops out there, is that we can have cover or infiltration rates that exceed 6 inches per hour. Let's go to the next one. The other one that we've spent a lot of time on looking at lately is just how hot are soils under conventional tilled systems. And this is a long-term study. We had 12 years of research going on under both corn and soybeans. We're looking at the surface temperature, and we're looking at the 1-inch temperatures in there. And if you just look at the graphs on the right side, that kind of orangey piece on the top is when those temperatures exceeded 40 degrees centigrade or 104 Fahrenheit. Because 104 is where we begin to degrade proteins, and we basically become lethal to biological activity. And so you can see a lot of cases, like in 2010, number of hours, 120 hours of that part between planting and emergence, and that we took it to about the 6-leaf stage of corn and the third trifoliate in soybeans, and all of this. You can see that there are a lot of hours that were lethal to biology. So a lot of times what we're doing, we realize that we're cooking the life out of our soil when we've got bare soil exposed, even under Midwestern conditions. If we look at a cover crop system, we look at a residue management system, there's none of those temperatures that exceed basically 90 degrees. Most of them run around 86 at the maximum. So they're in that sweet spot for biological activity to have a real impact. Let's go to the next one. The other one, and those are the short-term impacts, and we could spend a lot more time talking about that. But let's talk about the long-term impacts of cover crops. Let's go to the next one. If we think about this, I'm going to introduce you to a new concept today that we've been spending a lot of time on, and that's how much energy we're putting into our soils that can sustain our biological activity. And so this diagram here is typically of what we have over a growing season. That yellow arrows on the top are sunlight energy coming in. You realize that in June, July is our maximum energy. And then the red lines are how much we're putting out, respiring back out of that system. And so we have a lot of energy exchanges going on throughout a whole growing season. How do we begin to capitalize on that understanding to help us change what's going on in the system? Let's go to the next one. And if we think about this system and everything, and I'll just use this simple little diagram. The one on the left is that if we have a typical corn soybean system, we're growing from basically June through September. We have a limited time for input. We have losses due to tillage at the end of the season. You know, when we till or we do anything else, we're not putting energy back into that. But if we add that cover crop, basically we're just extending the time throughout the season in which we're capturing energy. We're putting it in, we're not disturbing that soil, so we got minimum losses due to soil disturbance. Really, this simple little change in terms of this says how much energy we're putting back into that. And let's go to the next one. And so we look at this carbon energy flow path, because we talk about carbon relative to sequestration and everything else, but in reality, there's a step back before that. And that is that we have to realize that carbon is our energy source. And if you think about plants, we take sunlight, we through the process of photosynthesis, we take CO2 and water, we create this simple sugar, glucose. We take glucose and we move it from that leaf into the stem. It goes down, some goes down to the plant roots, some goes into root exudates that leak out of the root as well. That sugar is what feeds the microbes and what feeds the soil fauna. Those two things have direct impact on our nutrient cycling as well as our carbon cycling. You look at the nutrient cycling piece, we can put it back into plant nutrition or food nutrition, all these other things that we know we derive from crops. In carbon cycling, we put it back into ecosystem services, water retention, water quality, diversity, all these other things that go on that we really try and understand how it all works. But it all revolves around how do we capture that energy and put it back together. Let's go to the next one. And if you look at this in terms of soil processes, there's an article, and I want to pay attention just to the x-axis on this, because that is the time scale in which these things are occurring, is that a lot of our microbial activities are in a matter of seconds. If we think about soil organic matter changes, it's much more in that yearly time frame. It all starts with, again, with that diagram that we had on the previous slide. We're taking carbon out of the atmosphere, we're putting it into that, we're putting it through a lot of different pieces out there. And so we get all of this different dynamic going on within that. And so let's go to the next one. What we see in our exudates is that somewhere between 40 and 50% of what's fixed in carbon in the leaf is actually exuded from the roots. And so we've got a lot of sugar that's going into that soil that leaks out of the roots. They're primarily glucose, and then fructose, saccharose, and ribose, all the different forms of sugars that are out there. And that most of that's still going into CO2 because of the microbial activity that's going on, and then 2 to 5% ends up in soil organic matter. So there's a lot of cycling going on. There's a lot of biology, and that's really what that last piece is. That just like you and I, the more we exercise, the more CO2 we release. The same thing in terms of biological activity is one of the major indicators of that is what happens with our CO2 exchange. Let's go to the next one. I want to dispel a fact that soils don't change very quickly. And this is a study that we started in 2016, where we took a field that had been conventional tillage. We put it into a no-till cover crop system. We extensively sampled this field. That's the top graph in 2016. We sampled this field on 150 foot by 150 foot grid down to a depth of 4 feet. And we looked at the microbial biomass that was there in the fall of 2016. A year later, we went back and sampled that upper 6 inches of that soil, and you can see as we all that green area is where we've increased the microbial biomass. And so within 1 year, we'd already begun to change the microbial biomass. Within 1 year, we'd already begun to change even the soil organic or the soil aggregates within that system as well. Let's go to the next one. If we look at this and why this becomes important, it's all about water. Across the Midwest, is that our function is to take sunlight and CO2 and the water, obviously, now because the other part of photosynthesis, convert that into profitable grain or whatever we want out there. We know there's a difference among soils. We know there's a difference among available water. One of the things that Hudson showed is that the more organic matter we put in the soil, the higher the available water content. I just put this into a different graph at the bottom of this slide, showing that as we increase organic matter, we change the days of available soil water. And what we did on this is we assumed a 5-foot profile. This is just a simulation with corn in August when it's transpiring at its maximum rate, silt loam soil, that if we went from 2% organic matter, we had about 8 days of available soil water. But if we jump it up to 4% organic matter, we're up in excess of 13 days. So we have 5 more days of available water in which that plant isn't stressed by being able to transpire at maximum rate. That's where yield's coming from. Anytime we stress that plant, we also begin to limit yield. Let's go to the next one. This is just another diagram showing that if we permanent wilding point, that's the point in which water can't be extracted by roots, and then the upper one is the field capacity, that's maximum amount of water the soil will hold. And just looking at that green graph, so if we reduce organic matter, we change that size of that area under there. If we move it up, go to the next one, we increase that amount, and so we realize that we can change this, and that's the long-term impact of that. The short-term impact, as I said before, is just getting water into that soil as well. Let's go to the next one. One of the things that we've done, and I've spent a lot of time over the past years looking at, and these are data from Wayne Frederick's farm, where he's adopted no-till or strip-till and then cover crops, just looking at what changed within soils within fields. And this is the Ostrander loam at the top and a Franklin silt loam. We did this for 10 different fields and multiple soils within each of the fields, is that every one of them showed as we improved our organic matter, is that we changed the distribution of those yields within a soil. The skewness, we took all those low yielding parts of that soil out. We made it tighter about the mean and everything else. So we began to change that field, and that's just, 14 years is still relatively rapid. We see this all the time going on. And so this increased uniformity is paying dividends for producers. That's where profitability is coming from, because in the 2005, you're putting a lot of inputs into that, but not getting a yield return. Like on that Franklin for 2017, you're getting a return on every bit of inputs that you have out there. You still have some low yielding parts, but not near as much as you had in 2005. And we saw that across all the different soils that we have. Let's go to the next one. So if we think about this functionality, taking it back to where we first started, is that we can positively change soil function with energy inputs. And that's where it really leaks into the biology of this, because biology requires energy inputs to grow, maintain, and change. You and I, we have a certain caloric input that we want each day that we need to just to sustain our life. If we want to grow, then we've got to have excess energy coming into that. And if we want to really change that soil, we even have to have more energy. And so it's really an energy-based system. We need to be understanding that as we're going along, because the biology is what changes our soils, and the biology is what requires the energy inputs to be able to make those changes. We know that cover crops protect that soil, so they alter the water and temperature dynamics that influence the biology in all of this, and that the cover crops provide that energy for that biological system. Because they're extending that growing season, they're putting more in there, but they have a short-term and a long-term impact to this as well. Let's go to the next one. And so here's my contact information, in terms of all of this. So, and we'll have questions at the end, but I look forward to having that discussion as we go along. So Jean, I'll give it back to you.
Great. Thanks so much, Jerry. That was lots of data there, and I think I stumbled on all those multi-syllable words in your bio, and I think you did a great job sailing through your presentation. So I will shift gears. Jerry mentioned we'll be doing questions at the end. So again, a reminder to put any questions you have for any panelists in the question box here. And I will shift now and introduce our second presenter. Kirk Kimble is a 5th generation farmer from Marshall County, Illinois. Kirk's great-great-grandfather started farming in central Illinois around the turn of the 20th century, and the Kimble family has farmed there ever since. He and his wife, Tiona, farm together with their 3 daughters, who have all been involved in Future Farmers of America and are great help on the farm. And Kirk, you're kind of a guy after my own heart here, because it says when you began farming, you tried no-till in order to save money by not purchasing more equipment. So it sounds like you're one of the frugal farmers that I've worked with, and you liked the results and now practice no-till on every acre. So, just one more thing, Kirk does share that with like big rain events occurring more frequently, you're really seeing benefits of no-till and cover crops in terms of keeping erosion at bay. And so Kirk is going to share a little bit about his farm and what he's seeing in terms of some of the nutrient management aspects. So I'll let you take it away here, Kirk.
Thank you. Welcome everyone this afternoon. Everything is no-till except acres that we've picked up. Sometimes they have to be leveled out or whatever, but after that we go into cereal rye rotation after the corn, and then we'll on the bean stubble, if weather permitting, we'll try and get something on there in the fall. The top left corner there, that's our air drill that we built. It has Dawn dual seed units, and it's on a case pivot toolbar so that we travel quite a bit. And then that's what we use to seed our cereal rye in 15-inch rows. It's 16-inch base planter, case IH planter that we plant with the soil discs, or the Martin closing discs for breaking up the sidewall. And then the air drill is a 32-row planter, so it splits on each side of the corn rows. Then we're using that air drill this spring. We side dressed with it too. And if you can go to the next slide, please. So this would be corn planted in. That's actually planted in the cereal rye, which for guys starting out, that could be an issue, but we've got our soils pretty well set up, and we're applying nitrogen side dress at about that side this year with 7.5 inches on each side of the row with that air drill. And these are past slides, but we've used cereal rye, annual rye, vetch, oats, radishes, sunflowers, and sun hemp after wheat. Next slide, please. And then this would be going into large rye that, in all honesty, kind of got away from us. At the time, we thought it got away from us. What we learned is that it builds an extreme amount of biomass, and which in turn is carbon and organic matter. And we try not to let it get that big just for control purposes, but we can survive that if it does happen. You just have to be flexible. And that the picture on the right is cereal rye and radishes in the fall. They're seeded. Right after, and then the lower one would be, that is actually for 3-inch rain event. The rye was still standing. And then I think the next picture will show you, we move on to the next slide. Yeah, the top right one, that was same picture a little bit later. We'd sprayed right, whoop, can you go back? There we go. The top right picture is that rain event with the water coming across the road from a conventionally tilled field. And then the lower pictures, that one was just kind of a 13-acre test strip of just rapeseed that I just did an experiment with, and that's what it looked like in August. And then got a lot of animal activity on our mixes after wheat. They're pretty fun to watch. And then that mix there, I think that was 26 inches, and that mix was planted, I think, around the 1st of August, and that was a month later when I took that, and that was after wheat. Next slide, please. So we've done these organic matter tests. Started out at different times, and we've cycled through. Some of these farms have been over 12 years, and we've cycled through, and we've raised some of them quite a bit. It just depends on which ones we had the most cereal rye on, and the wheat ones. A lot of times the farms that I'm focusing the wheat on are on timber soils. They'd be the lower organic mattered soils anyway on the timber, and we've raised them, but it's taken a lot longer. We can actually see larger responses in a quicker time frame on the, say, 3.5% organic matter. We can gain on them just because of the extra biomass. And then we have another, we'll go to the next slide here. This is our 2021 soybean yield versus organic matter. And on the right there, you get up into the 5% organic matter. My theory on why they're lower in that higher one, which it seems like that shouldn't be the answer in the slide going across, but more than likely the 5 to 5.5 is a very wet area that has some water issues, and I think that's how that turns out. But there's a really strong correlation as far as the organic matter to the yield that we've come across. And on to the next slide. So we're controlling weeds with the covers. Every now and then we can get away with without that second pass if we have that extreme amount of biomass. I don't always have it, and if we don't have the biomass, usually water hemp in the middle of the season is still going to be a problem. We'll have to make the extra pass in the beans to hold it. But next slide. So these prices were actually last fall when we created this. So everything could have changed here, but we have reduced our corn nitrogen use by 25%, but a lot of these farms have been cover crop for 10 years, and we're seeing we can get away with this. I'm not going to tell you if after 2 years of using cover crops that you're going to be able to reduce your nitrogen that much and be happy with your yields, but we have some farms that we're comfortable with doing that just because of the history on them. Going from that, but that kind of works in with the way we're doing things, and we found that, and I mean, we have a history that we can show how that has happened, and we're still increasing yields. So we'll go to the next slide. And then this is just kind of the bushel increase since adding the cover and the bean yields, and we've reduced fertilizer overall by 25% and still increasing yields in that slide. Next one, please. So here's our summary on our questions. We've increased the soil organic matter less weed pressure, reduced nitrogen, less erosion, and increased yields. This can be done. Everything that Jerry touched on, I believe wholeheartedly in. We're doing it across a large amount of acres and spaced out. It's working well for us. You have to be flexible, and sometimes you have to change your plans and be willing to do something different if the weather doesn't work in your favor. You have to be patient if you have that large amount of rye out there and get your seed trench closed. So you still have to do everything correctly, but it is all completely possible. I believe in it wholeheartedly, and we're seeing a lot of interesting things that just keeps getting better over time. But it does take time as far as visually seeing things happen and getting the history on it. I guess that's where I stand. So if any questions later on, it'll be great to answer them. Anything else, Gene?
I know you got through that in good time. Thanks so much, Kirk. Yeah, hoping we'll get, I know we have some questions prepared. I have questions I'd like to ask you, and we'll have some time to run through those and learn more about, I'll cue you up, Kirk. One of the things I'm interested in is at what point did you decide you could start reducing those inputs? So we can maybe get some perspectives from Frank and Jerry with that question as well, but I'll kind of give you something to think about while we listen to Frank's presentation. So yeah, with that, I'll set up Frank here with his introduction. Frank Rademacher farms with his father, Eric, on a 600-acre corn and soybean farm in Champaign County that practices cover crops, continuous no-till, and input reduction. Frank graduated from the U of I in 2018 with a degree in crop science, focusing on integrated pest management, and he works as a conservation specialist with Precision Conservation Management, or PCM, where he enjoys using his agronomy background and on-farm experiences to help other farmers make effective conservation decisions. So yeah, thanks Frank for joining us today, and looking forward to hearing your presentation. And we talked before about maybe the need to rush, but there's no need to rush now. We are getting through the content in good time here.
Yeah, don't tell me that. I'll still keep it pretty quick because I can. This is one topic that I could go on forever. So no, I'll still try to come out under time, and that way we've got a little bit more time for questions at the end there. So again, thank you for having me. My name is Frank Rademacher. I won't rehash a lot that was in the intro there, but I was asked to speak about weed control in a cover crop system and kind of what we've done, and just to kind of tie that back to why we're having this presentation today. There's a lot of inputs where you can call up your retailer. It's a one-off thing, add this, decrease this, and it may not impact your overall operation that much. But what we're doing with cover crops, to use them properly, we're really basically changing everything. So if you can obviously try, you don't have to try it to the level that we have. But eventually, if you want to get the most out of it, really promoting the cover crops as the biggest part of your system is advised. So next slide, please. So like Gene said, we farm about 1,000 acres, about 60% of it is owned, 40% custom, and of that, so about 650 acres is continuous no-till and cover crops since about 2018. And as she mentioned, I'm also involved with Precision Conservation Management as a conservation specialist. Really, what we focus on is data. How do conservation practices stack up financially versus other practices, and then give out a lot of agronomy advice, and then funding as well. Next slide, please. So just a quick background. I always like to say that, you know, it seems like we've always been this way, but really we haven't been doing this that terribly long in the way that we've been doing it. So I always like to tell people that, you know, we started out the same way as everybody else. So aerial application and killing it early, and really just getting our feet wet, and that's a perfect place to start. So 2018, everything, all of our ground that we own transitioned to continuous no-till and cover crops. And that's where we're at now. I've kind of got some of that listed that we do. So we have a drill now that we use on our acres, plus some custom acres. We have a planter mounted roller crimper that came from Dawn Equipment that we rely on as the base of our weed control program, using cover crops to reduce our reliance on insecticides, and almost everything we have is non-GMO. And we've been able to back off on quite a few synthetic inputs. Next slide, please. So I wanted to touch base a little bit on integrated pest management. So that's what I went to school for. And basically the theory, the approach there is you want to approach pest control from several different angles. So instead of just planning on controlling your weeds with chemical, we have a whole host of strategies that we use. And a lot of that is planning ahead, right? I have there that it's proactive rather than reactive. So we just want to do anything we can to have a holistic view of weed control and pest control in general. So I've got listed there just some things that people use as a part of an integrated pest management program. Not all are related to cover crops, but most of them are. Ones that I like to include out of there, beneficials. Don't often get as much credit as they should, but crickets eat a ton of seed, right? So if we can use even the little tools like that, that definitely helps us in the long run. Crop rotation, obviously in this part of the country, we don't have a whole lot of options for crop rotation, but so we're using cover crops to kind of fill that gap. And then because we want to maximize our cover crops, we've also changed our crop maturity planting date to help get the most out of that system as well. And obviously we are on no-till, which is a strategy that we use. Next slide, please. So just some cover crop considerations from weed control standpoint. The biggest one that I can think of, and all of these I should say are things that we still think about, but things that even whether you're a beginner or you've been doing it for 10 years, you have to think about almost every year. So number one would be species selection. And really your target there is your carbon and nitrogen ratio of your residue, which impacts your nitrogen tie-up for your next crop. So, and a lot of this depends on goals and what you're able to plant into. So I usually explain carbon nitrogen ratio. High carbon residue is something like corn residue, right? That's going to stick around for a while. Whereas low carbon nitrogen ratio residue is more like bean residue. So the usual approach would be to use a high carbon mix ahead of beans because they can take it. They're not too they don't get too affected by nitrogen tie-up. Whereas something in front of corn, you want a lower carbon nitrogen ratio residue. So something again like bean residue, like legumes, brassicas, that kind of thing. Like I said, we are changing our crop maturities to get cover crops in a little earlier in the fall. Again, we want that growth, and usually if you can get cover crops planted a little earlier, a lower rate goes a little longer. So anything we can bump up to bump up our fall health of our cover crop stands. Fertilization practices, I won't talk too much about that, but again, adding cover crops is not just another input. Every other piece will affect the cover crops, and if you're putting some form of fall nitrogen down, you're going to see it in the cover crop. So plan accordingly. Like I said, cover crop growth period. There are weed benefits that you can get from a relatively short amount of cover crop growth period. The one that comes to mind is mare's tail control. That's probably the easiest bar to hit. That really just requires a cover crop out there, mostly cereal rye growing, and it'll clean up mare's tail pretty substantially. So that's something to think about if you do have a field that has mare's tail issues that you had issues controlling in the past. For what we're doing personally with non-GMO crops, obviously water hemp control is what we're looking for, and due to water hemp's emergence later in the season and its extended window, we do need a lot more growth out there. So cover crop growth period in relation to your goal becomes important. And then lastly is kind of a complicated one, but residue use and management. We've had years where we've left residue standing before we had the crimper. You know, how does that impact your crop in regards to shading? Or how does that impact your post herbicide spray if you're going to have one of those? You know, in terms of, say you've got a thatch of residue out there and you're using a herbicide that relies on full coverage, is that going to screw up your plans there? And then will you have lasting residue, and how will that impact future herbicide plans? So there's a lot to think about, and that's why we always recommend finding somebody to talk to that has experience in it. So I just wanted to give a quick overview of our weed control program in both crops. I won't talk about well, this is just our general program. Not all of this pertains to weeds, but I just wanted something up there so that if you're kind of wondering how we did something in the system, that you could at least see a snapshot of that. So population, trait, and this is in soybeans. And soybeans are my favorite. If there was a way that we could grow continuous soybeans, and there might be, with the amount of diversity we have, I think I would do that in certain fields. So again, non-GMOs, the premium is excellent, and really our goal there is non-GMO weed control is not getting any easier. So if we have a long-term system that allows us to continue to be able to grow those with low inputs, I think that has a lot of payback in the future. So like I said, there is no seed treatment on those. A lot of reasons behind there. We are planting later, like I'll talk about. But again, we are trying to promote beneficials, so less residual insecticide in our fields is really a good thing in our opinion. Row width is 20 inches this year for the first year. We had historically been on 20s. Crop maturity, so we are using 2/8, which is abnormal for the area. We don't usually plant anything over about a 3, whereas the average locally is probably a 3.5, give or take. And really the logic there is, if you think about what I had mentioned in regards to carbon to nitrogen ratio, the following crop would be corn. And for the following crop, we need a lower carbon to nitrogen ratio mix. And most of the time that's going to involve a lot of legumes and brassicas, which are a little pickier. Grasses are easy to grow as a cover crop, a little harder are legumes and brassicas. So if we can get the beans off early by using an early maturity group, then we can get those species established a little more successfully in the fall. The planting date, I've got there the 15th to the 30th of May, which is actually about when people started this year, but historically probably a little later for people. Being non-GMOs, I do like them in a little later. Gives our cereal rye, that's about the time frame that it flowers or pollinates, which is kind of the stage that you crimp in. So we do like to push that back a little later. Again, weed control is what we're going for there, and the ability to crimp and get it to lay down. The herbicide plan is interesting. That's always fun, and it changes every year. So again, in non-GMO beans, we will plant, and then that day, next day, we will still do a burn down, because there's always thin spots, bare spots that we do need to take care of, and especially since they are non-GMOs, since we effectively don't have a post option for emerged weeds, we do need to make sure that we start clean. So we'll come through with Roundup and 2,4-D to clean things up. And then we usually throw in 2 residuals in there. That again changes every year. It was Authority MTZ for a couple of years. This year we decided to go with Prowl and Metribuzin to better target some of the weeds that we're facing, and I'll kind of talk about that at the end. And then post, this is kind of the fun part. So for non-GMO beans, we don't post for water hemp. We don't put down like Flexstar or anything to get us more residual. If we do need to spray something, it's Cadet, and we may be the only people in the country still spraying like Cadet, but mostly Velvet Leaf, right? Because that's basically all that Cadet is good for. And really the thinking is there, we have a lot of residue, which is harder for smaller seeded weeds to come up through, but large seed broadleafs especially do pretty well getting through residue. So Velvet Leaf obviously is something that we do keep an eye out for. And sometimes grasses. Grasses occasionally will get through as well. But beyond that, there is no other residual other than what we put down at planting. So then ahead of beans, for this upcoming year, I changed my mind about 100 times throughout the season, but at this point it looks like it's going to be about 60 pounds of Elbon cereal rye, 6 pounds of hairy vetch, and 2 pounds of rapeseed. Next slide, please. So for weed control and cover crop corn, it's very similar. So I'll again hit the high points, and I'll probably just skim over the nitrogen plan. I wanted to just put that in there in case people had questions of how the heck we were managing all that residue. Again, fungicide only. We do actually put, it's difficult, but we do order all of our seed untreated, and then we put a fungicide on it just to get over that green bridge effect, because we are planting corn green into a lot of times a grass cover crop. So just to get away from root diseases if we can. That is also non-GMO, so there is some weed control challenges there, but we seem to do pretty well most of the time. We are on 20s on corn because we weren't quite weird enough yet. So we are 20-inch corn and beans now. Again, canopy, throughout the season, that cover crop is breaking down, especially if we've got a lot of moisture in a year. So ideally, by the time that residue mulch starts to break a little bit, we have a crop canopy to rely on. Maturity, again, is a little odd for this area. So most people probably in that 113, 14-day corn, and we usually stick about a range of 100 to 107. Again, just trying to get the most we can out of our cover crops there. I do have the nitrogen plan there. Herbicide plan, very similar. Roundup 2,4-D, 2 residuals. This year it was atrazine. Atrazine is nice because large seeded broadleafs, if they're emerging, and it gives us a little bit of control over those. And then prowl, because grass weeds and small seeded broadleafs are kind of what we're targeting there. Post, typically expecting none, but we usually do keep something like a Lautus atrazine. This year it was Caprino atrazine in case there was some grass on hand. And then the tentative cover crop mix there, 15 pounds of rye, so we try to back that down as much as we can. 12 pounds of vetch, but we do like to keep the rye in there, obviously, so the vetch has something to climb up on. And then we'll try about 3 pounds of rapeseed. And both of those mixes, a head of corn and beans, are about $40. So that's full disclosure. We worked our way up there. It was $10, $15 for years, but to get the most benefits that we're looking for, especially weed control, late season weed control and nitrogen production, we do need to spend a little more money. Next slide, please. So last couple of slides, just wanted to go over Crimping 101 for those of you that are thinking about it. So this is us planting our beans this year. This is a rye and vetch mix, and it was pretty impressive. You could you couldn't walk through it. So we're hopefully going to have pretty good results there. So one, thick stand. That's really number one, right? That helps it lay down a little bit, pull each other down. And I've got their vines for number 2. It's kind of nice to have different plant structures, again, to pull each other down and hold itself down. You have to wait until flowering if you're looking for a kill and to hold it down, otherwise it will come back up. Again, that 15th to the 30th of May is a good time frame to shoot for that. If you are going to do a mix, make sure that they mature at the same time. This year we had some barley in one of the mixes, and it was definitely not ready to crimp and stood back up. So it happens. And then cover crop variety, as you get more advanced in this, I had mentioned Elbon specifically. You're looking for it's like when you pick a crop variety, right? You're looking for various characteristics that are going to make crimping easier, whether it matures earlier, bigger stem, or more seeds per pound so you can get more plants per acre. There's a lot to think about, but if you can get the system down, it works excellent for weed control. Next slide. So then just to finish up, where we're at as far as results, we post spray in a normal year, depending on the mix of the fields and cover crops, about 25 to 50% of our corn. I think a lot of what we have to deal with now are sins of previous years, weed control. So I think as we deal with those, we will be able to spray a lot less. But corn is a tough one because, again, you're trying the line between enough cover crops to fight the weeds and too much cover crops that your corn sucks. It's a pretty thin line. So I'd be lying if I said we had it all figured out, but we're working on it. And then beans, we're very happy with our progress on beans. To really not be worried about a post spray for water hemp and non-GMOs is actually really comforting for most of the season. And just lastly, just the concept that we're working for is what they call a weed shift. So really the lineup of weeds that you have is really based on your production practices. One of the weed scientists, and I forget who it was, had mentioned that, like, if you were designing a crop production system that would work well for water hemp, like, you couldn't do better than corn, soybeans, and our current system. So, and that's why we have it. So really, we're just trying to attack that from every angle. And basically, we've created more or less a prairie. So like at the right there, those are weeds that I think are natives, like prairie natives that I find in our soybean fields, which is great. But primarily the weeds that we're dealing with now are grass, velvet leaf, dandelions, milkweed, horse nettle, hemp dogbane, which is weird, but it is cool to be able to use cover crops and no-till to really change our management and the weeds we need to plan on. And I think next slide. So yeah, that's all I got. There's again my contact information. That's my business card with our logo and motto and all my information. So if there's any questions and you want to get a hold of me afterwards, let me know.
Thanks, Frank. Yeah, that was really informative. At this point, we're going to shift to just the question and answer session. And so I'll invite Jerry and Kirk to come back on camera. And again, just kind of a reminder for you, if you're still looking for that question button, we have gotten some questions from the audience that we'll try to get through. And yeah, and I'm going to actually just kind of kick us off here with the very first one. And just, I think, Frank, you mentioned this, you know, that we're trying to bust some myths. And, you know, one of the myths, of course, is that we just treat cover crops like another input, which often causes part of the failure. So, Frank, you did a great job, you know, running through some of the changes you've made to this system in terms of hybrid variety selection, herbicide selection, planting date, harvest date, et cetera. So I just wanted to give Kirk an opportunity from a farmer perspective to share if he has made similar changes or what types of system type decisions have you had to weigh, Kirk, after the integration of no-till and cover crops into your system?
We haven't, we're still using fuller season varieties in that. I just want to, my main goal is to get all the corn stalks covered with cereal rye. Establishing something on the bean stubble, I'd love to get it done, but I don't really want to give up the yield right now from the 3.5 maturity soybeans. I'm not quite as far along as Frank, but I mean, I believe in everything that he's doing. I'm just doing it a little bit different. I want to cover there mainly for the rain events in the spring is my goal. And it took, you know, on a couple of the first fields that we'd had the covers on continuously, once we started testing and seeing the organic matter coming up, then everything that we've learned at, you know, just going to seminars and listening to Jerry and stuff like that, I had enough nerve and confidence to back off on some of the nitrogen and just experiment a little bit. And it was working, and I got more comfortable. And you know, after 12 years, you get these farms built up a little bit with the biological going on, and we've just slowly kept backing off. And like I said, I'm not going to tell you to go do that instantly in the first 2 or 3 years, because it's kind of a compound interest thing that you're building with these covers. So
Sure.
I guess that's where I stand on it.
Yeah, well, and I set you up, said I was going to ask you that question. So I think you mentioned nitrogen. Did either of you make any adjustments to P and K inputs after the use of cover
Yeah,
crops?
yeah, we've backed them down essentially about the same amount too. Like I said, this year we actually side dressed the urea with the air drill, and we just put a small amount of potash and sulfur in, and we'd put the phosphorus in with the starter fertilizer. So, and that's all. The only application of dry that we've done is actually banded beside the row this year. So, I guess that's where. Anything else on that?
Well, I guess I think you know, you mentioned you're not making that recommendation for farmers to just start cutting back on inputs, and I want to kind of tease that out a little bit more and just invite any of you to respond. You know, input prices are high, very high this year, and you know, expected grain commodity prices are also high. But you know, at what point did the input price forecast last fall make any influence into your management decisions, or perhaps it gave you comfort knowing, hey, I'm okay, I can reduce my inputs because I've built up my soil a little bit? Any thoughts on that?
Yeah, I mean, I guess I was a little braver because we've been kind of backing off for 2-3 years here on different farms, and I knew it was possible, and I kind of, with the economics where it's at, I come up with a plan, and we stuck with it and backed off. Like it's saying, the only reason I have confidence in what we're doing is where we've built the soils up to. If you know if you don't have the nutrient cycling going on in the past history of, I mean, we're getting rye that's still there 2 years later, as long as we haven't worked any of the farms and destroyed that stuff. That's all composting years later and releasing again. So it isn't all a 1 year effect on that with the rye, with large amounts of rye residue or wheat residue even. So I guess that's where we're at on that.
Great, thanks. Frank, do you have anything to add from your perspective in terms of just kind of evaluating the input prices and how, and more kind of foundationally, like at what point did you feel comfortable to start cutting back those inputs?
Yeah, I mean, most everything we've done has been very stepwise, and we're not too terribly impacted by input prices. That doesn't really, our general trajectory is regardless of input prices. So we just have a pretty stepwise plan just to back things off. And it started with what I would call like the low hanging fruit. And every operation has that. And I try to help other producers with that when we can. So, whether it just be like the MRTN nitrogen rate and using something like that, I think that's underutilized, especially in a year like this. But we did trials like a lot of little stuff like seed treatment. That was one thing that you just do trials on seed treatment. 1 year you back off the insecticide, the next year the fungicide, and see how that goes. And then we've been able to back off nitrogen as we've been a little bit more efficient with it. So like I had there on, I didn't talk about our nitrogen plan, but we basically went everything within 2 inches of the corn plant. So we go on the planter. So that's the first shot of nitrogen. We are starting to work in legumes, but using legumes to cut back on nitrogen is far from a science. It's more of an art. So we're haven't made much progress there. But yeah, by the time we put all of our nitrogen within 2 inches of the corn plant, I mean, that has a lot of efficiency in it. So slow and steady wins the race when it comes to reducing inputs, for sure.
Sure, thanks. And Jerry, in terms of the farms you've worked with, the research you've done, anything to add in terms of, and you actually showed some charts, you know, where the yield variability narrowed over 12-year difference. Was that just a slow and gradual thing, or do you think that there's sort of a year 3, there's kind of a sudden change, and that's kind of a comfort level that, and farmers can kind of use that as a benchmark? What are your thoughts on that?
Yeah, it's much more of an exponential. I think Kirk kind of showed that as well. I mean, it's things start changing, and then it's a compounded interest, and once it starts increasing, it increases even more. And it's a matter of observing your fields, observing that yield monitor, and looking at the variability within those fields. I've talked to a lot of producers that have changed like this, and I think Kurt would probably agree with this. Is over time they've seen an increased uniformity within their fields. Frank probably has too. You know, and you don't have to go through all that rough statistical analysis that I did that uses those 2 statistical moments that nobody ever paid attention to before. But you know, I think that a lot of this, and you know, if you get to a point, and I think this is where you could use something like strip trials and just run a different rate of nitrogen across the field compared to what you're normally doing, and see, excuse me, if there's any change in it. And going back and just doing simple yield monitor comparisons. You know, and it's a matter of, I think, going out in the field and looking, you know, what's that corn look like, and even what's those beans look like late in the growing season. You know, if you've got enough nitrogen and that biology is working, you see a lot of really green material, particularly on the lower leaves late in the growing season. That tells you that biology is cycling nutrients, making them available. That's one of the indicators that's out there. So I think that producers need to be paying a lot of attention to what's happening late in the season in terms of this. That's an indication. And I think just being willing to ask questions in terms of this, and doing simple leaf chlorophyll measurements. That tells you a lot about you know, what's going on within that as well. So, and ultimately the yield test at the end is always the the proof in the pudding, I guess, and everything in terms of what's going on. But not being afraid to look spatially within the field and saying, you know, is this field really changing? Are there parts getting better or not? You know, and so this is a complex world. We got things that are changing in this. I mean, you know, I was loved listening to people like Kurt and Frank, because, you know, you just begin to understand the complexity of the system we're dealing with. We got all these weed pressures, and we've got nutrient management, and we've got decisions made on cover crops, and then we have this one little variable we can't control, and that's called the weather. You know, and we see that changing our responses from year to year. And so I think we've got to be patient with some of this, but also I think there are great opportunities that we can evaluate our changes in field quicker than we often do. Because we're looking for things like soil organic carbon, which is a pretty slow response compared to the rest of the things we're talking about.
Mm-hmm. And you mentioned in your presentation about the importance of the water management piece that can come with cover crops. And I feel like, you know, your comment about the complexity of the system and trying to, it's almost like we're trying to read the crystal ball, right? So there's actually kind of a crystal ball question here in terms of, you know, the climate predictions are looking at more precipitation in the spring, drier summers, and I think intuitively, and there's probably there's data out there that shows that covers can help regulate the water. Maybe you can just kind of talk through that a little bit, maybe from a data perspective, or you know, where can we be looking to actually proof in the pudding in terms of the benefits of water retention from cover crops?
Well, I think there are 2 things that are happening within our, well, probably more than 2, but I'll just talk about 2. 2 things that are happening in our precipitation cycle. We know the annual precipitation is going up, and we know that the seasonality is changing. We see across the Midwest, we're seeing a shift to more spring precipitation and a more variable summer. And then coupled with that, a lot of our storms are more intense. You know, we pick up that 2 inches, 3 inches in an hour sort of phenomena. And that's been going on for the past few decades, and that's increasing as well. So it says that we need to be thinking about how we manage our water. How do we get it into the soil, and how do we keep it there? And the cover crops do that. I mean, Frank's rolled down cover crop. You know, it basically is still that mat that absorbs all that energy. So if you ever look at what's really going on out there, you get this heavy rains, it's all coming on and is slowly dripping through that. So we maintain that infiltration rate. And then that mat prevents it from evaporating back out. So we keep it all right there. You know, so one of the things that we need to do is keep increasing our storage within that. And, you know, ultimately we get the organic buildup that also increases our water holding capacity. But the first piece is basically this physical change that's going on. So, you know, and I think that, you know, managing our water supply, because we can't control how much sun we get. We already got an abundance of CO2. So the one variable that's out there in that whole photosynthetic process is water. And being able to make sure that that plant has a lot of available water to drive that photosynthetic process to create the sugars that we all process is really where we need to be thinking long term.
Sure. There was a couple questions from audience kind of teasing out some specific habits of cover crops. So there was one question around, and maybe this is for Frank or Kirk, you know, whether you've heard any concerns or had any pushback from neighbors that your cereal rye might be either hosting pests or pathogens for their crop, and or this is maybe me inferring this, you know, whether there's any concern about the rye going to seed and then becoming a weed in someone else's field. So maybe can either of you touch on that if you've had any experience in terms of rye getting out of hand?
Sure. At least where we are located, as far as rye as a volunteer is probably a little scarier, more in wheat country than where we are. It's just not going to be able to fill in the conventional tillage corn and soybean rotation very well. So not really worried about that. I think in regards to, I don't think we would be for diseases. I don't think that would have any impact on their pests. I think if anything, we are like anti-pest. I mean, we probably reduced the total load of pests in the area because, I mean, the beneficials we have are really incredible at this point. I mean, spiders that you would not believe. It is, and ground beetles, all kinds of stuff. So I think we probably have a net negative on pests in the area.
Kirk, anything?
Yeah, we had some trouble when we first started aerial, when they turn and dry boxes on the airplane and that. So that was one of the main reasons I built the air drill. And then we get a much better stand with seed to soil contact, and then you're not having anything get out of your own field that way. So that was probably the biggest issue, was the aerial. I mean, you can cover a lot of acres with it, but you do have accidents, and you can have issues that way. But we're mainly with the air drill. I haven't had anything. I mean, you may get some strange looks when you have cereal rye that's 6 feet tall and you're driving through it, but other than that, that's about it.
So there is a question, and it's well timed because I don't think it would hardly be a cover crop webinar or discussion without the mention of slugs, maybe. So, you know, do either of you have slug issues, and how do you control that, or what are your advice for someone who is concerned about slugs?
I mean,
Frank,
personally, we've never had an issue with them. I think one thing that helps us a little bit is getting the cover crop down, because when I do see them, they are hanging out in that mat, just eating whatever plant material is down there. as far as any kind of impact on the crop, I really don't see much feeding. I've seen more slugs like climbing up mid-season corn plant than I have like early season soybeans. We don't really deal with it for some reason. And you know, being insecticide free, got to throw that little plug in there. A big predator of slugs are ground beetles. The issue with using a soybean insecticide treatment is that the slugs are not killed by it, but they become toxic. So I think if our ground beetle population is, so if we can not use that insecticide, the ground beetles should be able to take out a fair amount of slugs.
Fair enough. Kirk, anything to add?
Yeah, I'll be honest, I've not had any issues with slug issues either. So I guess we have had a little bit of trouble with voles and pockets, but it's not a big enough issue to, it's not economic as far as I'm concerned. It's more of a visual impact than anything. So.
Okay, great.
I guess that's all I have.
That's good news for you guys. We'll let the other people who like to bring up slugs every time, maybe they'll have better luck at the, the next webinar, because I have heard that it's a challenge for some folks out there. And I guess, so thinking more then also about cover crops and the weed suppression that you get out of it, you know, one question came in terms of whether you think the weed suppression is more from the allelopathic properties from the rye, or is it really more about getting the biomass and the shading on the soil to compete and prevent germination?
I say it's probably a little bit of both. Measuring an allelopathic effect is kind of tough, in my opinion. I think we get, for the weeds that we're targeting, right, it's a small seeded broadleaf water hemp that really depends on some sunlight. So sunlight and hot temperatures. So if we can keep it cool, keep it covered, I think that's where you're probably getting, and suck up some nitrogen. I've heard there is some kind of a maybe some germination of impacts of nitrogen levels in the soil. I think beyond, with all those things, I think is where we're getting the biggest bang for our buck there.
Kirk or Jerry, anything to add to that?
Yeah, I think Frank's absolutely right. When if you can keep that soil covered and keep the sunlight off of that, you see, just go out in the field and look where you've got skips and stand in a conventional till field where you see the weeds. It's always in that spot, keeping that residue on the cover and not getting sunlight down to it, and keeping it cool and moist. And then you got biology that eats those seeds as well. And so you created a perfect ecosystem for things that like to consume small seeds to have a food source. And so, you know, I think a lot of this, again, it's about how these pieces fit together, and you know, it's really about a management dynamic. Cover, reduce sunlight, less weeds, suppressing that, because once you reduce the weed population, that's a compound interest thing as well over time. And I think we need to understand that too.
Did you have something to add, Kirk?
Yeah, trying to just be flexible when you're if your cover got out of control or whatever, just realize that you can if you're patient, you can deal with a lot of problems. Even, maybe not say problems, but just difficulties of what's going on. And over time, you're going to realize, once you get used to the system, I mean, and there's a lot of different ways that you can address issues and change your plans if you have to in season. And once you get used to knowing when to run, because the soils are going to be different. I mean, when you get that mat out there, I mean, you can drive on it when you probably shouldn't be on it. And so you need to kind of adjust to that, but it's all able to be dealt with. So hopefully that kind of answers a few questions, maybe brings up some more.
Yeah, well, and I think there's one more question that I want to make sure we get to, and it's from someone who looks like a landowner, and they actually share the costs of the expenses of cover crops with their tenant farmer, which is kudos to this individual. Not all landowners do that. Yeah, I agree. So I wanted to make sure we called that out and give appreciation to that person. But this individual just asked, is there a mix, or and maybe we don't have that mix today. Maybe there's more of a broad question of where can this person go for information to really learn more about what kind of cover crop species would best kind of meet the needs of suppressing weeds and increasing organic matter. So maybe what all information and resources do you folks rely on when you're just starting out and learning? And maybe I'll start with Kirk.
Okay. I've been going to the National No-Till Conference for probably 15 years on and off. Don't make everyone, but that opened up a lot of resources, and just meeting different people and realizing that there's so many different ways to go about things. And I mean, there's a lot more information out there, but most everyone has someone in the area that's selling cover crop seed, and I mean, they're wanting to help you. I mean, they may have just as many questions as you do too, but through their seed supplier, they're going to have some very good answers too. So I guess that's kind of where I've went, but don't be afraid to travel and go get a different opinion from just all across the country. Listening to some broad-based speakers is kind of, that's opened my eyes to a lot. So
sure.
I don't know.
How about you, Frank?
As a specific answer. No, that's all right. Sorry, go ahead.
Yeah, I mean, I would
Frank,
say,
do you have any?
When we started out, like, this wasn't cool. Like, there was nobody you talked to. You were the only person you knew doing this for the most part. And now it seems to be in pockets, but I'd start local. If you know one or two people within a half hour or whatever that are doing this successfully or in various stages of success, just talk to them. That's probably the best place to go. And then, obviously these resources is what you want to build upon that with. But yeah, local resources are hard to beat.
Great. Yeah. Well, and I'll do a promotion for ISAP and the resources available on ISAP's website. Obviously, these webinars will be recorded and put there, but there's also links to great information sites and publications, et cetera, on cover crops and soil health systems. I'm going to turn it back to Megan, but before I do, I'm going to give one quick teaser for a question we didn't get to, which is a perfect setup for next week's webinar, and that was, how do we sell conservation? And it's a tough question, but we're going to try to tackle that next week on Tuesday. And I'll just give gratitude again to Jerry Hatfield, Kirk Kimble, and Frank Rademacher for joining us today. I really appreciated the conversation. And back to you, Megan.
Thanks, Jean. Thanks, Jerry, Kirk, and Frank. I was scribbling notes and papers to go Google after this. I really appreciate it. So we will go on to the next slide here and get you guys all out by 2:30. You can see on the screen there, if you are looking for CEUs, go ahead and get your CCA app out. You can use that QR code to the right. And if you don't have the app, we will be sending a Google form in the chat and in the follow-up email that you can submit your name and your CCA number to make sure that you get those hours. Also, a reminder to all participants, CCA or not, that we hope that you'll take 2 minutes to complete our survey. After the webinar ends, a window will open up on your browser, and we share this information with our funders and our partners just to build better resources in the future. So we really appreciate your feedback. And then finally, like Jean mentioned, the party is continuing for the next 2 weeks. We've got 2 more myths to bust. So next week, we're going to be gathering together on Tuesday, June 21st. And the registration link will also be dropped in the chat, but you'll also get that too in a follow-up email. And yes, ilsustainableag.org has all sorts of information and events calendars to keep up on to help you and your clients implement soil health and conservation drainage practices. So again, a deep thank you to all of our presenters and Jean for helping us moderate, and we look forward to seeing everybody next week. Thank you.